So, we will continue the discussion on combinatorics, and so in the we saw first that Pingala in his Chanda Sutra started this subject of Prastara, and he did this Prastara of the syllabic meters, and then he talked about the other pratyayas also, the Nashta, Uddishta, Sankhya, Lagakriya. Then the same thing was repeated for the Moric meters or the Matra Vrittas by Virahanka, Hemachandra and others. Now parallelly the same kind of discussion started in music also, and in some 11th 12th century works there are some talks of this kind of Prastara and combinatorics in music, but really the text in which the entire subject appears almost in a completely finished and a perfect form is the very famous text Sangita Ratnakara of Sharangadeva. So Sharangadeva considers two different kinds of combinatorial problems. One is Prastara of Tanas of Swaras. He also considers Prastara of Talas or the rhythms. So as you can see, both are going to be discussed somewhat extensively in this talk. In the end, I will make some remarks on the relation between the idea of a Prastara and theory of representation of numbers. Sharangadeva, his Sangita Ratnakara is one of the most famous treatises on music in India. It is said to be prior to the period when classical Indian music divided into the Carnatic and the Hindustani forms. So, it is a canonical text for both the streams. He was a Kashmiri Brahmin by descent. They I think came to Devagiri one or two generations earlier to him, and he was, his father was in the Singhana, Yadava king Singhana's court. Singhana is said to have ruled in Devagiri from 1210 to 1245. So Sharangadeva's work should be around 1230, 1240. Sangita Ratnakara is a complete treatise like Bharata's Natya Shastra. The first chapter is Swaradhyaya, next there is a Ragadhyaya, then there is one on compositions, then we have a chapter on Tala, and finally there is a chapter on Nartana. So it is a complete treatise. The sections on Prastara is very small in the Swaradhyaya, it is somewhere buried in the middle of the Swaradhyaya, but the section on Prastara is really very long in the Taladhyaya. There are two very famous commentaries, one by Kalinatha and one by Simha Bhupala, both of around 14th century. I think Simha Bhupala was the contemporary of King Devaraya in Vijayanagar. So we can straight away enter into the discussion of what is Svaraprastara. So basically what Sharangadeva is talking is again a mathematical problem. That is why it is not much discussed in music circles, though this section is an important section in Sharangadeva's book. So you take any three swaras, say Sari Ga. Now you can render them in various different orders. So in normal mathematical language they will be called permutations. So Ri Sa Ga, Ga Sa Ri, etc. So you have three swaras, they have a natural order between them, and then there is permutation, and so the number of permutation here is 3 factorial. So the moment you add the fourth swara, the number of permutations will be 4 factorial, it will become 24, and like that up to Sapta swaras you can reach 5040, 7 factorial. Now as regards this 6, it does not matter, you can always identify them, but suppose I ask you to write down all possible permutation of sarigama pa. Those are called the kuta tanas. So a phrase like sarigama pa is called a tana, and rendering them in a different order than in the natural order is called a kuta tana, and you need a prastara for all the kuta tanas, that is you need a listing of all these. So if you have 5 swaras, you have 120 permutations. So if I ask you to write them down again, as I said, the problem will be you would come, maybe you will write 30, 40, and then you do not know whether the next one that you are writing has already been written down earlier or it has not been written down, you have to check. So there has to be a rule by which you generate all these prastaras. So in mathematics this is called permutation generation today. So this 4th volume of Knuth's Art of Computer Programming is devoted, a section, 2 sections are devoted to permutation and combination generation, to give algorithms and then study them. And in fact the oldest algorithm for permutation generation and the perfect one is due to Sharngadeva, and this is the algorithm. Kramam yasya swaraha sthapyah purva purva paradadha sachedupari tat purvaha parastu parivartinah मूलक्रम क्रमात् पृष्ठे शेषाः प्रस्तार idrisha. So you start first with the swaras in natural order, sariga, and you should end up with swaras in reverse order. So that is the last row of the prastara. So the prastara for this looks like this. So what is the rule that Sharngadeva is giving to go from sariga to risaga, sagari, gasari, rigasa, so what is the rule by which Sharngadeva is saying you go from one row of this to the next row? So stated in words, the rule is as follows. So first row is write all the swaras in their natural order, then starting from the left, identify the first swara which has at least one swara lower to the left. Below that is placed the highest of these lower swaras to the left. Then the swaras in the right are brought down as they are. So this part of prastara is similar. In every prastara rule, you do something at some point, whatever is to the right is brought down as it is. Then there is some simple rule to fix whatever is to the left. The swaras left out are placed in the original order to the left. So this rule of Sharngadeva is indeed applicable to any prastara, meaning any permutation of a n ordered object. So let us look at this prastara 4 objects, sarigama. So what is Sharngadeva saying? From the left you start looking, whenever the swaras appear in an ascending order. So here at sari itself it is appearing in an ascending order. Before re, put down the lowest of the swaras, highest of the swaras below re here. So below re you put this sa, bring down this ga and ma as it is, and remaining swaras are put in ascending order to the left. So second row risagama is simple. Next, risagama, how to go to sagarima from risagama. So risagama, the ascending order is happening in saga, risa is descending, saga is ascending. So below this G, I have to put the largest of this, highest of this, that is re. I bring down the one to the right as it is, and in the left whatever is left out, re and ma have already been finished. So sa and ga have to be put in the natural order. So that is sagarima, next row. From sagarima, so saga itself is in natural ascending order. So below ga put this sa, bring down the re and ma, whatever is left out ga is put to the left. Next row, ga sa ri ma. So sa ri is in the ascending order, below re put the highest below re in the left, that is sa, bring down the ma as it is, whatever is left out, sama is here, riga have to be filled in here. Riga sama, so riga is in ascending order, below the ga put the ri, sama are brought down from the above, what is left out ga is placed to the left. Ga ri sama. So Ga, Risa is all in descending, only Sama is ascending. So before the Ma, put the highest that is below Ma which lies to the left, that is Ga. So before the Ma put the Ga, there is nothing else on the right to be brought down. The remaining swaras have to be put in the ascending order, Sa, Ri, Ma, Ga. So like this you go on. So you can take any line, Ga, Ri, Ma, Sa. Supposing, what is the next line? What is the next line? Ascending order, Ri to Ma is ascending. So highest before the Ma is Ga is to be brought down. The Sa is to be left as it is. Ga and Sa are over, Ri and Ga are only remaining. The next row is, I am sorry, Ga and Ri and Ma are what is left out. So Ri, Ma, Ga, Sa is the next row. Ri, Ma is in ascending order. Before the Ma, whatever is to the left which is lower than Ma should be brought are. Ga and Sa are as they are. So this next row is Ma, Ri, Ga, Sa. Next row, Ma, Ri, Ri, Ga is in ascending order. Before the Ga, put the Ri. Sa is to be brought down as it is. Ga and Ma are what is left out. So like that, from any point you can start, follow Shangadeva's rule and keep going down. So this is the rule. This can be applied to any permutation of n objects which have a natural order amongst them. So you, instead of Sarigama, you could have done 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, put the 1 there, 3, 4, 2 is left. 2, 1, 3, 1, 3 is ascending, put the 2 there, bring down 1, 3. So like that you can go on. So any permutation of any n objects which have a natural order, and in fact the same rule even applies when you have repetitions. Sasa, Ri, Ri, Ga, Ga, you can do a prastara of that. Obviously that will not be n factorial, that will be n factorial by n1 factorial, n2 factorial, number of identical objects. So that is called listing of multi sets. Those are sets which where objects can repeat and they are ordered. So even that can be done by the same rule of Shangadeva. In fact later on, if we have time, while discussing Ganita Kaumudi of Narayan Pandita, he has explicitly considered the prastara of permutations with repetitions we will do. So that is the rule of prastara, that is you order all the Kutatanas of the swaras in the form of an array going from 1 till the n factorial point. And as you can see in this, the first 6 end with a Ma, the next 6 end with a Ga, and the next 6 end with a Ri, and the last 6 end with a Sa. And what is 6? 6 is the factorial below 4, that is 3 factorial. And inside each of those blocks you will see they will group under 2 factorial, inside that they will group under 1 factorial. So the factorial numbers naturally appear in the construction of this prastara, and so just as the binary powers were natural in the syllabic meter prastara, the Fibonacci or the Virahanka numbers were the natural units in the Matra Vritta prastara. The factorials of integers are the natural units which will be used in discussing the prastara of Kutatanas. So let us just understand the rule of Kramam Yasya Swarasthapyaha. Put the first row in which the swaras are all in the Purva Purvaha Paradadhaha Sachedupari Tat Purvaha. So from left, if there is a one going up, put the one below that, Parastu Uparivartinaha, bring down all the things to the right as they are. Mula Krama Kramat Prishthe Sheshaha, the other swaras which are left out are put in the natural order to the left. So the complete rule of prastara is clearly encoded in this beautiful verse. Now obviously having constructed the prastara, we have to do the standard problems of given a row number, what is the permutation that appears, what is the Tana that appears in that row, given a Tana or a permutation, in which row of the prastara does that appear. So that is the next thing. So incidentally some history of this. So this way of ordering the permutations is what is called the Colex ordering in today. Now there is a simple ordering called the lexicographic ordering today. So you can start with 1, 2, 3, 4. What would be the next thing in the lexicographic ordering? You 1, 2, 4, 3, right? Then 1, 3, 2, 4. So like that it goes. From the left you keep on choosing the lowest one, only in the end you alter the things in the natural order. So that way of ordering things is called the lexicographic ordering. What Sharngadeva has done is a mirror image of the inversion of the lexicographic ordering, that is why it is called the Collex ordering, mirror image of Collex ordering. So if you take the last one, the mirror image of this is Sarigama. You take the next one, the mirror image of this is Sarimaga. You take the third one, Sagarima. So as you can see, when you read the Prastara from the bottom, the mirror image is the same as the what is called the lexicographic ordering. So Sharngadeva's prescription for permutation generation is what is called the mirror image of the co-lexicographic ordering of permutations. In fact, in 16th, 17th century lots of books were written on trying to list all permutations of say 8 objects or 9 objects, and invariably there would be errors found in the books because they did not have a systematic algorithm for writing down all the permutations, and I think some Frenchman discovered one algorithm around late 18th century, that is the sort of beginning of this subject in Europe. So now what is the way in which Sharngadeva discusses Nashta and Uddishta? So as I said, Nashta and Uddishta is given the row number, find out the Tana, that is Nashta. Uddishta is given the Tana, find out the row in which it appears, and for that Sharngadeva uses something called the Khande Meru. Let us not read the words, but just look at the Meru and understand. The first row is all 1 and 0, 0, 0. Second row is all the factorials, leaving out the first column, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial. Third row, leave out 2 columns, twice the 2 factorial, twice the 3 factorial, twice the 4 factorial. Next row is 3 times the factorial, 4 times the factorial, 5 times the factorial. So that is the construction of the Khanda Meru of Sharngadeva. It is like just you are going to divide these things by factorials. So it is like just like a multiplication table of factorials with which you will grade the things and identify the Prastara, meaning do the Nashta and Uddishta. The mathematical operation, just as in the case of Varnavritta, the idea you went on dividing by 2. That was the way you were doing the Nashta and Uddishta. Here you go on dividing by factorials, and instead of doing the division you use this Khanda Meru. We will again not read the thing, but take an example and understand how the Uddishta problem is to be done. To find the row of the Tana, Masa Riga in the Prastara of Sarigama. So this is a Uddishta problem. For Sarigama, you first write down your Khanda Meru like this. Sarigama 1 0 0 0 factorials, twice the factorials, 3 times the factorial. Then what do you do? Look up the last swara in the end and then identify in the reverse order where it stands among Sarigama. So among Sarigama, Ga is the second in the reverse order. So from the top you mark the second row. Then Ga is over, Masari is all that is left. So you take Ri. Now identify amongst the left out swaras, that is Sarima, what is the position of Ri in the reverse order. So Sarima, Ma to Ri, Ri is the second in the reverse order amongst the remaining Sarima. So again mark the second column in the next second row in the next column. Then what is left? Sari. So what is Ri in the reverse order among Sari? It is for I am sorry, Masariga is what we are doing. So what is left is Ma and Sa. So what is Sa in the reverse order among Sama, that is the second. So, again the second row, whatever is left is in the first row. So, I have marked these 4 numbers, add all of them, 1 plus 1 plus 2 plus 6 is 10, that is the row of Masariga in the Masariga is in the 10th row of the Prastara. So, using Khandameru, so we can take another example. Let us keep the Khandameru. So, let us take some other thing, Garimasa. So, what is the row of this in the Prastara of Sarigama? So, Sa is the 4th among Sarigama. So, you have to identify 1, 2, 3, 4, you have to take the 8, oh it will not come that way. So, you have to take this 18. So, this will be 18 plus Ma. Amongst Rigama, Ma is the first. So, you will just get a 0 in the second entry. Ma is the first in the reverse. Then you have Ga, Ri. Amongst Ri and Ga, Ri is the second from the top. Therefore, you have to take the second row in the next column, that is 1. So, this was the 4th, this was the first, this was the second, and this will be whatever is left, that is just this one here. So, this is what you have. So, you should obtain this in the 20th row of the Prastara. Let us go and see. Gari Masa is indeed the 20th row. So, this is the method of doing Uddishta with the Khandameru, and Khandameru is essentially a device for dividing the number by factorials and identifying where it appears. Now, Nashta. Again we will do it with an example. So, find out the 18th Tana in the Prastara of Sarigama. So, what do you do? The rule is as follows. In the 14th, in the last column, identify the number below the number you are looking for. So, the number below 18 is 12. Then subtract that 12 from 18, you are left with 6. Then in the next column, look for the number below 6, that is 4. 6 minus 4 is 2. Take this 2. In the next column, look for the number below 2, that is 1. 2 minus 1 is 1, this one. So, you have obtained these 4 numbers. From these 4 numbers, how do you identify the Prastara, the permutation? So, what do you do? Same thing, same interpretation, right? This is the 3rd row. So, in Sarigama, the last entry of the permutation is the 3rd in the reverse order from the end. So, that has to be Ri. Among Sarigama, Ma, Ga, Ri. Ri is the 3rd in the reverse order from the end. This is the 3rd row that is coming. So, I identify the Ri. Next, this is also 3rd. So, among Sagama, Sa is the 3rd. So, next is Sa. So, you have identified Ri, then you have identified Sa. Then you have the 2nd row here marked. So, amongst what is left? We have finished with Ri and Sa. So, only Ga and Ma are left. So, what is the second in the reverse order amongst Ga and Ma? That is Ga, and therefore, you have the 3rd entry taken Ga. What is left out is Ma. So, we can do one more example. So, find out, say the 9th row of Prastara. So, what you will get? In the last column you will get 6, right? So, last column just one more row. So, you obtain this 6, 9 minus 6 is 3. So, in the next column you are again obtaining this 2, which is just below that 3, this 6 is just below the 9. Then 3 minus 2 is 1, and this 0 is just below that one, and this one has to be used. So, the last entry of the permutation is the second in reverse order in Sarigama, that is Ga, and what is left? Sarima, amongst them again the second that is Ri, and what is left? Sama, amongst them the first is the reverse order, that is Ma. So, your permutation should be Sama Riga. Let us see whether that is indeed, that is the 9th row of the Shangadeva's Prastara. So, the Nashta and Uddishta are just done from the Khandameru. That is more or less it, because there is no Laga Kriya. Why there is no Laga Kriya? Because every Tana has all the elements and only once, and therefore there is nothing like how many times any particular element appears. All elements appear once and only once in the permutation. So, there is no further Laga Kriya, but just all this, that the Khandameru and whatever we have done is essentially based upon a very beautiful representation of numbers. So, I will just tell it to you in very briefly and we will proceed. So, in both the Nashta and Uddishta examples that I had given, the number 10 was broken down into 1 plus 1 plus 2 into 6, the number 18 was broken down into 1 plus 1 into 4 into 12, that is, each number is broken down into a sum of multiples of factorials, and this is behind both the Nashta and Uddishta process, and this can be generalized into a statement which is actually implicit in the construction of the Khandameru and in the Nashta and Uddishta process, that every integer can be uniquely represented in the form d0 times 0 factorial. 0 factorial is taken to be 1, d1 into 1 factorial, d2 into 2 factorial, etc., dn minus 1 into n minus 1 factorial, where di's are numbers less than or equal to I, di is less than or equal to I, it can be 0, d0 is always 1. So, this kind of a unique representation exists, and that gives a one-to-one map between the numbers, the rows, and the metrical the permutations. So, that is at the heart of Nashta and Uddishta. In particular, you have this very beautiful relation, n factorial is 1 into 0 factorial plus 1 into 1 factorial, 2 into 2 factorial, etc. Okay. So, we are half done. Actually, we are done with the simpler form of Prastara that Shangadeva did. He does all this in about 10-12 verses or something like that. And incidentally, what is Sankhya for these Prastaras? It is just n factorial, right. Tala Prastara is indeed something which is much more fascinating, much more complex, and the theory that Shangadeva has given, in fact, is more general than even what later people could do. The chapter 5 of Sangeet Ratnakara is Taladhyaya. It has 409 verses. The first 311 verses discuss what are known as Marga Talas and about 120 Deshi Talas. At the end of all this, Shangadeva says, no, the number of talas are innumerable and all that. So, I will tell you some mathematics that you can do with them, which will give you an idea of the kind of variety of talas that are possible. And so, he starts with the discussion of Prastara, Nashta, Uddishta, and he does various other things. The units of Tala that Shangadeva is considering are 4, and that is what is interesting, and that is somewhat different from the way the Tala units are in vogue today. The units he is considering, the Talangas, he is considering 4 Talangas: Dhruta, Laghu, Guru, Pluta. These are the 4 talangas that Sharangadeva is considering. He is giving them actually that temporal measure of half, 1, 2 and 3. So, if we put it down in integers, instead of this, this is in the ratio 1:4:6. So, there are 4 tala units that Sharangadeva is considering: Dhruta, Laghu, Guru and Pluta. Now, in today's music we know there are 3 units in the what are called the Sula, the Sapta talas, which are in vogue in Carnatic music since the time of Purandaradasa. There is something called the Anudruta, there is Dhruta, then there is Laghu, and the Sula, the Sapta talas are made out of these 3 components, and these Laghus can be of 5 varieties, right? Triputa, Chaturashra, Khanda, Mishra and Sankirna. Dhruta is of 2 units. This can be of units 3, 4, 5, 7 and 9, and this is of unit 1. So, these are the tala units currently in vogue in the Carnatic music as it is practiced. So, but these are the units that Sharangadeva is considering, and later on it is said that there are many manuscripts and discussions of these kinds of units also in late 18th, 19th century. There are supposedly many families of mridangam players and musicians who have written secrets of prastara for their children and for their shishyas in small monographs, but many of them are supposed to be around and most of them are not. There is one due to the Tachur brothers, etc. So, they have not been still been studied, but Sharangadeva has given a complete discussion with these 4 units. Of course, in the olden times, even in Sharangadeva's time, there used to be another unit called Kakapada. That was this Kakapada is also in vogue, I mean till recently, in complicated talas known as Sharabhanandana, Simhanandana and all that. So, these kind of units are also used in current music. Okay. So, now let us go along with Sharangadeva. People who want to update his theory for current tala units are welcome to make their attempt. There is Professor Akella Mallikarjuna Sharma in Hyderabad, who has written quite a few articles and monographs on this subject. He is a violinist. Okay. So, now the thing that is done is indeed a generalization of the Matra Vritta. What is done is a total tala amount of say 15 units. How many tala forms can be there? Made up of DLGP, which will give you a total of 15. So, this is similar to the Matra Vritta Prastara, where you had only just the Laghu and Guru with 1 and 2. So, to the 1 and 2, which now think we will call them 2 and 4, you are adding a 1 and 6, and you are enlarging the problem of partitions. These are ordered partitions of numbers made out of these, where repetitions are also allowed. So, the theory of Tala Prastara is indeed a generalization of the theory of the Matra Vritta Prastara. Now, in mathematics literature in India, in Ganita Kaumudi, Narayana Pandita did consider, he tried to make a generalization. Narayana Pandita tries to make a generalization of all the earlier discussions into a larger mathematical framework. So, he generalizes Pingala's Varna Vritta Prastara, which is binary representation, into a representation for an arbitrary radix, for an arbitrary base. Similarly, he generalized the Matra Vritta Prastara of which was in vogue, to considering any number of units, say LGP, Laghu, Guru and Pluta, with values 1, 2, 3, or with values 1, 2, 3, 4, or with values up to 1, 2, 3 up to Q, all the values appearing. But that does not include the peculiar kind of formulation that Sharangadeva has made, where the units are 1, 2, 4 and 6. So, what theory Narayana has given, so Sharangadeva's theory is indeed somewhat more complex and general. This appears in a music book about 150 years earlier or 100 years earlier than Narayana Pandita, but this is indeed more general than, at least Narayana generalization does not include this. Okay. So, now the prastara of these talas. So, if you have a dhrita only, that is one dhrita prastara, just that is all. Next is lagu, that will just have two, right, two dhrita prastara. This can be called one dhrita prastara, meaning one unit of time in the dhrita unit, 2 units of time. So, first you write a lagu, then you can write 2. So, what about the 3 dhrita prastara? It can be like this, right. So, this will be the 3 dhrita prastara. I have not written them down, okay. So, good, I am writing them down on the board. So, this will be a 2 dhrita prastara. So, this will be a 3 dhrita prastara. So, once you have 4 dhritas, a guru is the starting point, LL. So, then below the D there will be an L, you are right. So, then this will be D D L, then there will be a D D D D, this is all. This will be the 4th dhrita prastara. So, the rule is last row of the prastara is dhritas only. First row, depending on the number of units, put as many plutas. So, the basic units are D is 1, L is 2, G is 4, P is 6. Remember that. So, in the first row put as many plutas as possible, follow that by as many gurus as possible, follow that by as many L's as possible, follow it by D's. That is the first row. The last row will have only D's. Then same way, to go from any row to the next row, start from the left. Whenever a non-D element appears first, below that write the highest element that can be written below that. If you see a P, write a G below that. If you see a G, write an L below that. If you see a L, write a D below that. Then bring down the elements to the right as they are. Then on the left again fill up, starting from P's if possible, then G's, then L's, then D's, to fill in the total number of units that for which you are writing the prastara. So, it is the same rule. So, we can read the words of Shangadeva. Nyasya alpam adyat mahato adhastat shesham yathopari. Above the mahato, above the greater one, adyat, from the beginning, from the left, wherever there is a greater one, nyasya alpam, put the next one below that, shesham yathopari, the ones to the right have to be brought down as they are. Pragune vama samsthastu sambhave mahato liket. So, here from in the left, whatever big things you can write, you write. Alpana sambhave tala purtyai bhuyo apyayam vidhi. Keep filling it up till the number of kala pramana are filled up. So, let us take the sixth dhruta prastara. Sixth dhruta is pluta. So, below that write pluta, write a guru, on the left lagu. From the left, below the lagu write a dhruta, bring down the guru as it is, you need to make up 6. So, put a D. Again start looking from the left, below the G you have to write an L. So, to fill up 6, a G is possible, so write that. Again from the left, below this G you have to write an L, bring down the L as it is, an L is possible, so LLL. Now, below this L write the D, bring down these 2 L's as they are, in the left write the D. Below this L write the D, bring down this L. Here 3 matras are available. So, write an L first and then a D, like that you go on. So, I have written it both in terms of P, A, G, L and in terms of numbers 1, 2, 4 and 6. So, this has 19. Now, you can straight away see This has one row with ending with P, 2 rows ending with G, 1, 2, 3, 4, 5, 6 rows ending with an L, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 30, I think it's what, 10 rows ending with a D. And you can straight away guess what is going to appear, that in the prastara of n kala pramanas that you are doing, you first take the prastara of n minus 6 kala pramana, put a p in the end for all of them, right. In the prastara of value n, tala total duration n, you first start with prastara of tala of length or tala of duration n minus 6, to that you add a pluta, immediately that will become n. Then below that you take a prastara of units n minus 4, to that you put a guru on the right, then again you have finished your n. Next you do prastara of n minus 2 units, and to them in the last row you put a laghu, and finally you do prastara of n minus 1 units, in the end put a dhrita. So the recurrence relation for the number of rows in the prastara is Sn is Sn minus 1 plus Sn minus 2 plus Sn minus 4 plus Sn minus 6. The prastara of n tala units is constructed. So you can see this here in the 6th dhrita prastara, there is above 6 it is easy, because it is below 6 there will be some complications, because one or other of them may not exist. So it is best to see it in the 7th dhrita prastara. In 7th dhrita prastara you can see 7 minus 6 is 1, there is one row which ends with a pluta. 7 minus 4 is 3, and the prastara of 3 I have already written, it has 3 rows only. So there are 3 rows which end with a G. In fact this is DL, LD, DDD is what I have written here. You write that and put a G to the right, and this is S1, this is the prastara 1 tala unit which we wrote first, you put a P on the right. Next Sn minus 2, that is 5, unfortunately we did not write down the 5, we can write it down. So what will 5 units look like? You start with a G with a D on the left, right. So now you have to put an L there, an LD will appear. Below the L take a D, bring down the L as it is, an L can come here. No, here a DG will appear. So like that it will go on. We will have to write few more rows. So you can see it here, DG, all these things are having L at the end, DG, DLL, LDL, DDDL, GD, I have come up to that point, you can go on. So you put all that and put a L below. This is prastara of length 5, to which you put an L below, L to the right, so it will become prastara of 7. And finally this is prastara of 6 units which was done here, this 19 rows, you take these 19 rows and put a D on the right, so that will give you a prastara of 7 units. So in tala prastara the rule is the tala prastara of n tala units is made up of first n minus 6 tala unit prastara with a P on the right, n minus 4 unit tala prastara with a G on the right, n minus 2 tala prastara with an L on the right, n minus 1 tala prastara with a D on the right, and therefore the number of rows in the prastara is Sn is equal to Sn minus 1. So you can now write down. So this is what Shangadeva is saying, ekadvyankau क्रमान्यस्य युञ्जीतान्त्यं पुरातनैः द्वितीय तुर्य षष्ठाङ्कैः अभावे तुर्य षष्ठयोः. So basically he is saying dvitiya is the second previous, turya is the fourth previous, shashtha is the sixth previous. So abhave turya shashtayoh, I think till 1 to 5, meaning 1, 2, 3, 4, 5, you will have 6 is absent here, 4 is absent here. So there you use the third and the fifth. Likhet dakshina samsthaivam ankashredi vidhiyate yad anka yogat antyonko labdaha taihi antata kramat bhedaha dhrutanta lagvanta gurvantascha plutantakaha. The 4 numbers of which the given number is a sum are indeed those prastaras which are ending in dhruta, lagu, guru and pluta. So that is what he is saying, and so these numbers can now be tabulated. So this is the recurrence relation. So we can call these numbers as Sharngadeva sequence of numbers. So the numbers are 1, 2, 3, 6, 10, 19, 33, 60. So this 60 here is equal to 33 plus this Sn minus 1 plus 19 Sn minus 2 plus 6 Sn minus 4 plus 2 Sn minus 6. Similarly, this 106 is 60 plus 33 plus 10 plus 3. So like that each one is composed. This is all generalized Virahanka sequence. So this is the Sharngadeva sequence. Now the rest is doing all complicated calculations of Nashta and Uddishta with this sequence. So I will just give you a glimpse of how it is. We will not be able to go into the details of it. We are already running little bit short of time on this. So I will just tell you how the Uddishta is to be done. That will give you, this is the generalization of the way Uddishta is done for the Matra Vrittas. What did we do for Matra Vrittas? We said write the Virahanka numbers. For a Guru write 1 above and 1 below. For Lagus write 1 above. Sum the numbers above the Gurus. That is the Uddishta process for the Matra Vrittas. Now what is the Uddishta process for the Tala? So let us take some problem. Now I think I have enough examples put in here. So what do you do? Write 1 Sankhyanka above D, 2 above L, 4 above a G and 6 above a P. Sum the following Sankhyankas. Later on we will see these Sankhyankas which are summed are called the Patita Sankhyankas. The first Sankhyanka above each L, the second and third Sankhyankas above each G, second, fourth and fifth Sankhyankas above each P. So let us see. The row number of the Tala form is obtained by subtracting the above sum from Sn. So to find the row number of LD LL in 7 Dhrita Prastara. So first write L D LL, write 2 Sankhyankas above L, 1 above D, 2 above L, 2 above L. Nothing above the D is to be summed. The first number above the L is to be summed. So 1 plus 6 plus 19, that is 26, 33 minus 26 is 7. So LDLL is 7th row in 7 Dhrita Prastara. LDLL is 7th row in 7 Dhrita Prastara. Another example, GDL. Write 4 Sankhyankas 1, 2, 3, 6, 10, 19, 33. These are the Sankhyankas. So write 4 Sankhyankas above G, 1 above D, 2 above L. Sum the second and third above G and the first above L. That is what it says. First Sankhyanka above each L, second and third Sankhyankas above each G and second, fourth and fifth Sankhyankas above each P. So second and third above G, first above L. So you get 24. 33 minus 24 is 9. GDL is 9th row of the 7 Dhrita Prastara. Last example, PD. So again above the Pluta write 6 Sankhyankas 1, 2, 3, 6, 10, 19. Above the Dhrita write 1 Sankhyanka. Sum the second, fourth and fifth above the P. So that is 18. 33 minus 18 is 15. So 15th row of 7 Dhrita Prastara should be PD. So that is the PD that we are seeing. So the reverse will be the same numbers will come as Patita Sankhyas. What we did in Matra Vritta was start subtracting. If you want to find out the 8th row in the 7th Vritta Prastara, subtract 8 from 33, you get 25. Then write the Sankhyankas, see which can be subtracted from 25. 19 can be subtracted, so 25 minus 19 is 6, and then 6 can be subtracted, 6 minus 6 is 0. So this 19 and 6 are Patita Sankhyankas, this 33, 10 and 3, 2, 1 are Apatita Sankhyankas, and then you have this what is called the template with which you compare. If you have an A, it is Dhrita. If you have an AP, it is a Lagu. If you have an APPA, it is a Guru. If you have an APPA, it is a Pluta. Of course, that followed by Apatita. So you use that template, immediately you will get DDDL. So it is all very nicely worked out in the mathematics in terms of the Sharngadeva Sankhyas. The idea of Patita Sankhyankas is a generalization of what was done in the Matra Vrittas. Another example, 28th Tala Forum in 7th Vritta Prastara, 33 minus 28 is 5, only 3 can be subtracted from 5, 5 minus 3 is 2, next 2 can be subtracted. So only 3 and 2 are Patita Sankhyankas, rest are all Apatita. So you have an A, P, P, A, that is the sign of a Guru, the rest are all Dhritas. So the Tala Forum is a GDDD. Finally, Sharngadeva also constructs, he constructs a Lagu Meru, a Dhrita Meru, a Pluta Meru and a Guru Meru, because given a Tala Forum, given say 15 Matra, 15 Dhrita Prastara, how many Tala Forums are there with 1 Pluta, 2 Pluta, 3 Pluta, etc. How many Tala Forums are there with 1 Dhruta, 2 Dhruta, etc. 1 Guru, 2 Guru. Now you can even ask more complicated question, 2 Gurus and 1 Dhrita, because you have 4 elements now. Earlier you are only having 2 elements, so only one choice was made. So all these are there. They are very, this entire Prastara section of Sangita Ratnakara runs to about 100 verses. He constructs something called Samyoga Meru, Dhrita Meru, Lagu Meru, Guru Meru. These are the kind of recursion relations which are at the basis of these Merus. So in all it is a very nice mathematical exercise. So ultimately in all this kind of combinatorics that we discussed, what is the message? So in any enumeration, any objects which can be enumerated, you have first a Prastara, an array, and then once you have an array, you can ask for questions like row number and what is the object that is sitting in that row number. You want an association. Then you have something called Laga Kriya, how many rows satisfy a particular property. So these were the mathematical questions that Pingala identified, but below this there is a mathematical issue also, because once you have to identify a row number with a forum and a forum with a row number, you will immediately see with a number a certain representation will immediately be associated. So in Pingala's Varnavrita Prastara, we had every number written as a sum of 2 to the power various powers of 2. In Matravrita Prastara, you saw every number was written as a sum of Virahanka numbers or the so called Fibonacci numbers. In Tana Prastara, you saw every number was represented in terms of factorials, and in Tala Prastara every number can be written as a sum of what I showed just now as the Sharngadeva numbers. Later on we will discuss Prastara of combinations. Prastara of permutations has been given by Sharngadeva. Prastara of combinations can also be done. Narayana Pandita does that in Ganita Kaumudi. That gives you a representation of all numbers in terms of binomial coefficient. So once we have this array and associating numbers with forms, immediately you will get a mathematical formulation relating natural numbers with a certain representations involving the Sankhyankas of that array, and this is at the bottom of all this mathematics that we have discussed. Thank you very much.